All right, let's dive right in. Today, we are talking about the absolute backbone of modern cloud networking, the AWS Transit Gateway. If you've ever looked at your cloud network and just thought, wow, this is getting way too complicated, then you are in the right place.
So let me ask you this. Take a hard look at your cloud architecture right now. Does connecting all your different VPCs, maybe your on-prem data centers, does it feel like you're trying to untangle a giant knotted up ball of cables? Yeah, if you're nodding along, trust me, you are not alone. And this number, this really hits the problem home. If you have just 10 VPCs, only 10, that all need to talk to each other, you would have to create and manage 45 separate peering connections. 45! It's just a nightmare to manage. It's super easy to make a mistake, and it just doesn't scale. Not at all.
Okay, but what if you could just get rid of that whole tangled mess? What if you could replace it all with one single central component? Well, that's exactly the idea behind the AWS Transit Gateway. It's a completely different way of thinking about how routing works in the cloud.
So what exactly is an AWS Transit Gateway, or TGW as you'll hear it called? The easiest way to think about it is like a huge, super-powered virtual router that just lives in the cloud. It's this central hub where you can connect pretty much everything, all your virtual networks, your physical data centers, everything. It's designed from the ground up to make your network simpler, not more complicated.
And this comparison right here says it all. On the left, you've got the old way, that messy web of connections we've been talking about. And on the right, the TGW way, a clean, simple hub-and-spoke model. Now, the absolute key here is that phrase, full transitive routing. All that means is VPC A can talk to VPC B just by going through the central hub. They don't need a direct connection anymore. And let me tell you, that is a total game changer.
So we know the Transit Gateway is this central hub, but how does it all actually work under the hood? Let's peel back the layers and take a look at the core pieces that really make this thing tick. So right at the heart of it all is the Transit Gateway itself. It's a regional resource, so you'll have one for each AWS region you're in. But don't let that fool you. This thing is an absolute beast. It really does act like a massive virtual router that can handle thousands, literally thousands of connections, and it just scales up and down with your traffic automatically. And of course, it's highly available by design. So how do we connect things to this hub? Well, we use what are called attachments. And you can attach pretty much anything you can think of. You've got VPC attachments for your cloud networks, VPN and Direct Connect for your on-prem data centers, and you can even have a peering attachment to connect to a whole other transit gateway in a different region. These are the spokes in our hub and spoke model. Okay, but how does the transit gateway know where to send everything? It's actually a really simple three-step process. First, a packet of data comes in from one of your attachments. Second, the TGW looks up the destination in its route table. You can think of that as its internal address book. And third, it just forwards the packet to the right destination. It's simple, it's fast, and it's incredibly powerful. And this is where the real magic happens, because you have complete control over those route tables. You associate each attachment with a specific route table. You can let the TWA automatically propagate or learn the routes from your VPCs. You can add your own static routes for special cases, like a firewall. And this part is so important, you can use multiple route tables to completely wall off your networks from each other. That means your dev environment can be on the same TGW as your prod environment, and they will never, ever be able to talk to each other. All right, enough theory. Let's get into the fun stuff and see how all these pieces come together to solve some actual, real-world business problems. The first and maybe the most common use case is the one we started with. It's all about taking that tangled mess of connections and turning it into a clean, simple, and actually manageable network architecture. Think about it. That 45 connection mess we talked about, it gets replaced by just 10 simple attachments. And because of that transitive routing, every single VPC can now talk to every other VPC just by going through the hub. The amount of time and headache this saves for developers and network admins is just enormous. Next up is a huge one, especially for security folks. Instead of having to manage firewalls and internet access in every single VPC, what if you could funnel all of your network traffic through one single centralized choke point? With a transit gateway, you can do exactly that. You can route all of your internet-bound traffic to one special egress VPC. And in there, you put all your security tools, your firewalls, your intrusion detection systems, your NAT gateways. For a security admin, this is an absolute dream come true. It gives them one single place to monitor, filter, and log every single packet that leaves the network. Now,
This central hub idea isn't just for internet traffic. Think about all the services inside your network that everyone needs to get to, like DNS or authentication tools. Instead of building them out everywhere, you can centralize them too. So you create a single shared services VPC. This is where you put stuff like your Active Directory, your logging servers, maybe your monitoring dashboards. Then every other VPC can get to those services right through the transit gateway. For solution architects, this is just a super efficient and cost-effective way to design things. So far, we've really been talking about a single geographic region. But what if your company is global? How do you securely connect your stuff in, say, North America with your resources over in Europe or Asia? Yep, TGW has you covered here too. You can actually connect your transit gateways in different regions using a peering attachment. What this does is create a private, secure, high-speed connection that runs entirely on the AWS global backbone. You're basically building your own private global network. It's incredible for things like disaster recovery or building low-latency global apps. Okay, now for a more specialized feature, but one that is incredibly powerful and solves a problem that's been a real headache in the cloud for a long time. Let's talk about multicast traffic. So multicast is basically a one-to-many type of communication. It's absolutely crucial for things like financial data streams, video conferencing, stuff like that. And before TGW, doing this in the cloud was frankly a huge pain. But now it's natively supported. For developers in those fields, this is a massive win. It means they don't have to deal with complex, specialized hardware anymore. So, now that you've seen just how powerful Transit Gateway can be, let's wrap up with a few key concepts. Think of this as your blueprint for a really successful implementation. Okay, 3 things to always remember. First, use AWS RAM, that's the Resource Access Manager, to share a single TGW across all of your different AWS accounts. Second, when you attach a VPC, make sure you designate one subnet in each availability zone. This is so important for high availability. And third, turn on TGW flow logs. They are absolutely essential for security audits and for troubleshooting when things go wrong. So we've seen how the AWS Transit Gateway can take a complex, tangled mess and transform it into a simple, scalable, and secure network. It really is the foundation for your entire cloud presence. Which brings us to one final question for you to think about. Your network is your cloud's foundation. Is yours really built for the future?